Let's move now to the second programming technique that we will be seeing in this session, and it's called list comprehensions. Let's suppose that we have some task where we need to create some list, and let's make just one app so we can discuss about it. And I'm going to suppose that I need to build a list of cubes, of numbers to the power of 3, integers to the power of 3. So the first one will be 0, the second one will be 1 to the power of 3, which is 1, second one will be 2 to the power of 3, which is 8, 3 to the power of 3, which is 27, and so on and so forth. I can do that very simply with just a for loop. I define the length of my list to be 10, for example. The list of cubes that I will output, I initialize it as an empty list, and at each step of the loop, governed by the number of elements that I wanted it to have here with range. So again, a very classical traversal loop here. I just append in each iteration I to the power of 3, and I get, as you can see, the list that I was looking for: 0, 1, 8, 27, 64, 125, 216. Okay, if I want to do it not for 10 but for 50, I get a much longer list with everly increasing numbers, but it works basically the same. Let's make it shorter for visualization purposes. Again, this is all fine and good and works perfectly, no problem. And if you haven't programmed in Python before, that's probably your go-to solution. But in Python I can do things more compactly, and as you will see, faster too. And to do that, one way to do them is to use list comprehensions. I will only stop here today in list comprehensions, but I encourage you guys to have a look at dictionary comprehensions, which work very similarly, except that in dictionaries you need pairs of key and values, as we have seen extensively in the second course in this specialization. But apart from that, the philosophy of the thing and even the syntax is pretty similar. So I encourage you guys to have a look at them. And let's see here the slightly simpler version of list comprehensions. List comprehensions are a very special type of expression that allows me to create lists in a very compact and easy way. And the way to do that is to just write my list name if I want to put everything into a variable, which I will surely want to do. And then I use the square brackets that enclose any list, and here I have my expression to create my list. That expression is usually made of something that I want to add to the list at each iteration, and then a for expression for example, for I in iterable, as I have written here. Let's use this way of writing for this thing. So I want to create my list cubes again. I'm again defining n to be 10, and the expression, what I want to add at each iteration is I cubed, so I to the power of 3, and then I have my for iteration, for I in range of n. Okay, so you can see that I have basically cramped my loop inside of a different expression, but that has mostly the same components. You might be thinking, am I getting something out of this? Because yeah, this is shorter, and it is, but not that much shorter, and the components are all them there at the same time. And I want to make an important distinction here. Here I am telling Python by using this that I'm building a list. There is nothing in the syntax of the loop that requires me to be building a list. Okay, I'm doing it here because I'm using a list comprehension. And when I build a list, I'm going to generally be occupying consecutive memory. I'm going to be doing the same thing approximately at the same iteration. So that's why this expression is more restrictive and can be further optimized. Because Python knows more or less what it is doing, and it is giving me some options and some flexibility, as I will see in a moment, but not all of the flexibility that I would have in a for loop, where I basically can do whatever I want. Then this is going to be quite a lot faster. Okay, so this is more specialized, is going to be faster, but I don't have as much freedom. Let's just run this and see that we achieve the same thing as before. Okay, and we can do it with 52, and we will get again similar list with increasingly large numbers, of course, because they are cubes. I said before, Python is going to give me some flexibility. Okay, so let's suppose that we don't want to do a list of just the cubes, but that we want to have something slightly more complicated. Like, for example, we want to have the cubes of numbers in even positions and the squares in odd positions. So I'm going to have a list that's called C or SQ, C, cube or square. And what I'm going to do is that in the expression part of the list comprehension, I'm going to have a function call. Can do that. The function call will just give me either the cube or the square if the number is odd or even. Okay, notice that this is something called a ternary operator in Python. And again, you can have a look at it, and I encourage you to do so. But let's just say that this very brief, very simple function gives me either the cube or the squared, depending on whether or not the number is even or if it's odd. Okay. So I have the same structure for I in range, although here I have a function call. So Python is giving me some flexibility to use things that can be as complex as I want here. I could do very complex things if I had more complex functions. Okay. And if I run this, I get 0 and 1, which is the square of 1, 8, 9, which is the square of 2, 64, which is the cube of 4, 5, which is the square of 5, and so on and so forth. So this is doing exactly what I wanted to do. And these comprehensions allow for some more flexibility. I can even use if. In the first expression that I wrote, I only wrote for I in iterable, but I can complement that with for I in iteral if condition. So I can add an if condition here, and I can do something a little bit more complicated. So let's make a list that only includes the numbers that are both multiple of 3 and 7. So I have a limit as I used to have, so I have the same for I in range of limit, but now I have added an if clause. So I will only add elements to my list in this list comprehension if they are both multiple of 3 and 7. Okay, so when I run this, I get 0, which is of course multiple of any number, 21, 42, 63, 84, 105. Okay, so numbers that are at the same time divisible by 3 and by 7, multiples of 3 and of 7. This allows us to control how many elements we want to have in the list. Notice that I used this if clause here after the for to choose some elements that I want or don't want to add to my list. I could also do it with the expression here. Here the expression was very simple. It was just I, but I could add an if clause inside of my expression. I can also do that. So let's say that I want to create a list that contains the numbers that are multiple of 5 or minus 1 when a number is not multiple of 5. So I can do that. I change my expression to I if I is a multiple of 5 minus 1 if it's not. And then I have just the 4 and I don't have the if after the 4. Okay. And I can even combine the two notations. Okay. So here, for example, I make a list that only contains numbers that are either multiple of 3 or multiple of 5. So I have an if expression here, but then I'm going to write different things. So my first expression is also different. I'm going to write I when a number is either multiple of 3 or multiple of 5, but I'm going to write I and so the number as a string with 3 exclamation marks if a number is multiple of both. So in this case I have the usual for the list comprehension, an if clause after it, so I can choose what elements I include and what elements I don't include, and a pretty complex expression, so I don't just include the iterator variable but something that's made with it, and I get my list with all the numbers that are multiple either of 3 or 5, and when a number like 15 is multiple of both, I have these 3 exclamation marks. I can even nest list comprehensions. Okay, so I can do it so the expression part of a list comprehension is another list comprehension. So here, for example, I'm creating a list that contains the points in a regular grid, 2D points in a regular grid, and basically I'm having a first main list that iterates over I, so at each position in that big grid I have all the numbers that start by the same element, so all of those start by 0 in my regular grid. But then what I return here is actually another list comprehension. You can see the second list comprehension here. So for each I create a list of that I and then quite a lot of j, which are tuples. So at each position of my outer list is an inner list with all the elements changing in the second position. First list of the big list, second list of the big list, and so on and so forth. I can use list comprehensions nested. I've been saying quite a lot that using list comprehensions is faster than using just for loops. Let's just check it. I'm going to make a small code that only takes a dictionary that I have created here that has pairs a number and a string, and it, for example, if the number is 2, the string is user2. Okay, so this is the dictionary, and now that no one is listening to us, this is a dictionary comprehension, the one that I told you before to go check out. Okay, but let's just imagine I have a dictionary and I just want to iterate over the values of that dictionary and then append them to my list. Okay, so I can do that with a very simple for loop, or I can do them with that with a very simple list comprehension, or I could do it by just taking the name.values iterator and feeding it to a list creator. Okay, so these are the two that we have been discussing, and this is to show you that Python has many other pre-built-in things that can help. Okay, and just going to run this. All the things are very similar in terms of code. The ones that don't use for loops are slightly more compact. Okay, but as is important to see, using a for loop in this case with what's this, 10 million elements, gives me takes 1.52 seconds to compute with a for loop. 0.37 with list comprehension, so that's quite a big time gain, and 0.29 with the creator of list, which is even faster than list comprehension and even narrower. Okay, so I can only create lists that work just adding the next element in the iterator to the next position in the list at every moment. Okay, so this is all we are going to say today, apart from one more example a bit later about list comprehensions. We use them to build lists, and they allow us for quite a lot of flexibility. I always have a for, but I can have expressions that can be complex if I want to, and I can choose what elements I include and I do not include by using a final if clause inside of my list comprehension expression. And as we have just seen, they are quite a lot faster than using for loops.